Hey guys, how's it going? My name's Rigo, and you're about to watch how I fix a Peavey Transtube 112 EFX. Now, just a little bit of background. I got this amp for around 40 bucks and it wasn't working, so I took it on a mission to try to fix it. I've never fixed an amp before, so you're gonna watch how I make some mistakes and try to fix this amp in a way that you would hear just watching the video and YouTubing and gathering whatever resources that you can to try to fix something like this. So I'm going to be chiming in every now and then, try to give you more context, try to give you a little bit more of the information that I learned throughout the way so that you can take this information, build upon it, and then maybe share it back in the future for people like us that are watching YouTube and trying to fix things that we never fixed before. So without further ado, let's get to the video. Let me show you this amp that I bought. I got this Peavey Transtube 112 here on the bench. And I'm not an expert at these things, but I decided to watch some videos and try to find out what's happening. The amp is not giving me any sound at all. At first, it was giving me some sounds, but then it was sounding very muffled. I opened it up, and it was one of these things here, one of these capacitors. If you can tell, this one is smaller than this one. And I have seen some videos and heard that this capacitor, this IC, I don't know, Indiana capacitor, I'm not sure where it's from, but these are all IC branded capacitors, that they go really bad right away. And so, I decided to just kind of open it, see what's going on, see if I see anything burnt. I know that if a burnt capacitor is on your board, then it's not very good. For the amp at all. And sure enough, one of these was just floating around. It was just completely out. It was burnt. The leads got burnt. So I decided to buy some of these Bojack, what is it, 2200 MUF 50 volt capacitors. I installed one, and that gave me some sound back. However, then it makes some really weird noises, and all of a sudden it stopped. I heard kind of like a big chirp or something, and then no sound whatsoever. And then the smell of burnt started happening. So I think this is a good time to pause and explain what's happening. So when you open an amp, you might be overwhelmed because there's just a lot happening. And without a mental model of how to connect things, it could be really hard to decipher what's going on. So I created this quick diagram here that's going to explain how an amp works so that you can have this mental model as you go through it. So obviously we're going to have a guitar going into the preamp first, then it's going to go to an output section, then it's going to go through the output transformer, and then the speaker. The preamp has all of our tone shaping logic. The output section will have more of the gain stages and the power of the amp, how warm that's going to sound, and the transformer is going to transform that to the specs of the speakers that we need. Now on the other side over here at the bottom, we have the power from the city coming in as well, and the power supply needs to has a very important job here. It needs to convert all of this AC to DC, as well as change the voltage from 120 or 220, depending on where you live, so that we can power the various components throughout the circuitry in the preamp and in the output section. Typically, if you have problems where something smells burnt, there's absolutely no sound, you might have a problem more with the output section or the power supply and any of the components that may be inside there. I'll get deeper into what's going on inside of these as we go through the video, but I just wanted you to have this mental model in your head so that you can understand a little bit more how the amp is working. And so I've spent the last couple of days trying to figure out what was wrong, and sure enough, I found the issue. So the issue is currently, let me see if I can set this down here. This is the power amplifier integrated circuit. It essentially creates around 68 watts of power at around 4 ohms, and it's the LM3886T. and this is by PM. By some, I think the top part is some manufacturer. But if you take a look there, I think that's what got burnt. And I can tell if you look at it from an angle, it's actually broken right there. I can even feel it. Yeah, it's not supposed to be broken. And I think this uses this thing as a heat sink. So I'm pretty sure I have that to replace, but I did already replace the capacitors. One of the capacitors, I'm going to replace that. And so I fixed that. I'm just going to fix the rest of the capacitors, replace that chip, the power amplifier chip, and see if that's going to fix my problem. But right now there's no sound whatsoever. And so I'll post back once I replace that chip. So I think this is a good place to pause and talk about what this chip is, what is it doing, and what could have caused this chip to go bad. So here you're looking at the manual for this chip. This is an LM3886 audio power amplifier running at 68 watts. This chip is essentially giving us the power that we need to drive the speaker. In a valve amplifier, this would be the power valves that are preparing the sound from the preamp and add color to it and actually be driving the speaker. In our case, it's a solid state amp, so it is this one. So it's a fairly important part. If this goes bad, you're not gonna have any sound at all coming out from the amp. It's almost as if the amp has no power to the speaker. No hiss, no nothing. But what could have caused this problem? So I think this is important to go back to our block diagram and find and expand the power supply area and the output section a little bit more so that we can perhaps try to trace where this problem could have been happening. And so if we expand those two areas, we'll get a diagram like this. So the city will send us the power. It will first go into the power supply area into the transformer. The transformer is going to transform that power from high voltage to the various voltages. It can have actually multiple outputs at various voltages. We also have fuses in the power supply area. This can be something critical as well, as if you have a blown fuse, you're not going to get any power whatsoever. But after the transformer creates and outputs all the voltages that the entire amp will need throughout, then the rectifier takes the signal, and this is responsible for turning that signal from an AC to a DC signal. Now, it doesn't create a very nice DC signal. It's actually quite a harsh signal. If you would listen to this signal, it would be very hummy, very hissy. So we need to do something else to prepare this signal before we send it over to the output section. And that's when we'll have a smoothing section. This will be made out of capacitors and perhaps other logic that I'm not very familiar with, maybe resistors and so on and so forth. But the entire goal here is to take the DC, the very rough DC signal, and smooth it out so that we can send it over to the output section. And then finally, we will have our power valves or our op amp. What failed with us is definitely our op amp is broken. It is burnt, right? So we know that. But that means that the problem could have been the smoothing section, the rectification, the transformer, or the fuses. Now, I checked the fuses. That was one of the first things I checked. The fuse was fine. So definitely not a problem with the fuse. We did note that the capacitor, one of the capacitors was wrong, was actually just kind of plain, just loose, it was off, right? So it was completely off. It wasn't even connected to the board. That was the very first thing I noticed. And so we definitely know that was a problem. So what could have happened is that the city sent us the power, the transformer might be okay, the rectifier might be okay, and some capacitor went bad, and therefore that burnt our power amp. Now, that is my best theory of what happened. However, it could also mean that the rectifier actually went bad, and that actually burnt the capacitor initially, which then caused the power amp, the op amp to burn. And it can also mean that our transformer is actually bad, and that burnt either a rectifier or that burned a rectifier, and which burnt our capacitor, which essentially damaged our op amp. So I'm thinking at this point I should probably be checking all of these three things so that I can really make sure. But for the next few minutes, what you're gonna watch is me simply replacing the op amp, replacing some of the smoothing capacitors, and then attempting this fix and seeing what happens. So anyway, let's get back to the video. I just wanted to add that context so that you have that mental model when you're watching the video. Hey guys, so here's the broken chip. So that's the LM3886T, and yep, as you can see, pretty damn broken. And here's a new chip, one LM3886T. This is supposed to be from Texas Instruments, but I don't know if it's any better. Alright, so the new chip is installed, and turned out pretty good actually. So here's the new chip, and here's the back, fairly clean. Also, here's the four in the middle are the ones I replaced. You can tell because they're not as smooth as all the other solders. So I'm just gonna clean up a little bit of the excess there, but that's done. Now I'm just gonna replace. I actually didn't replace the other ICs. They look fine. I could tell that there was some little bit of burning on this one, but the other ones look fine. All right, guys. So here it is. It's fixed. So it was just those two things. Well, actually, I replaced two capacitors, two of the bigger ones. These are the 2200 microfarad 50 volt capacitors. I replaced them from the ICs to the Bojack capacitors, which you can find for like $10 for a pack of 10. And I also replaced the IC. This is more the integrated circuit power amp. So let me just pause here a little bit. It was actually fixed at this point, and I should have just left it as is. But as I mentioned previously, I was trying to do a mod which later burnt another chip because I think I shorted the thing to ground. I'm kind of getting ahead of myself, but just, you know, word of warning, it was fixed for now. I should have left it as is, but I didn't. You'll see. Which is this chip that I've been talking about, the LM3886T. Make sure it's the T on it. Make sure you wired it correctly and you put it on the heat sink. There was actually a small piece of glass in between the heat sink and the chip. I think that's so it doesn't make contact. I don't know, but it looked like it was put there precisely. And I'm trying to lean into here because of the camera there. I think it was put in there precisely, so I kind of left it. I don't know about these things. I just know basic soldering and basic, you know, like YouTubing to fix things. So I left it in there, but it turned out to fix the problem. Before, it used to just turn on. Here, let me just turn it on here. This is why I wanted this amp. It's just so nice for a solid state amp. Like, I'll have a deeper video on this. I mean, that was the modern tone on a kind of telly style guitar here. Alright guys, so I'm going handheld here. I have the amp again on the bench. This time, I mean, everything was fixed until I decided to do this mod here. Essentially, this is a panel jack for just plugging in the speaker cable on and off, so that I don't have to be pulling on this. That's right on the PCB board. And I think what I just did really poor ends, and I killed my fuse. So this is so painful to watch. You can see how my tone changed. I was feeling very down at this point. So just a little recap of what I did off the video, off the camera. Everything was working fine. I gave you guys that quick demo, and I was very excited, and I was saying how much I liked the tone. And then I came in and I actually replaced these two cables here. So these two cables here I replaced, which were the, just the output cables from the board to the speaker. Now, originally these cables go through the chassis, this hole in the chassis. It was protected by some plastic so that they don't rip into the cables, and then they go directly into the speaker via some clips. What you see on the video right now is actually a different jack. Right. This is one of the attempts I tried to add a quarter jack. I don't know why I was trying to do this so hard. I was almost compelled to do this just because all my other amps have this feature, and so I ended up. Well, you'll see, right? This wasn't working very well. Well, first of all, here it looks really ugly. This is my second attempt at it. It looked much cleaner on the board, but yeah, essentially what I did is I drove some of my signal to the chassis, which essentially sent a direct hot signal to the chassis, which is not a good thing. You're gonna blow your fuse, right? The fuse is designed whenever there's too much current coming in, blow the fuse to protect you. That's essentially what happened here. So I blew the fuse. I am talking about maybe the clips being bad. I don't think that's what happened. I think I actually was sending some hot power to the chassis. But anyway, let's get back to the video and see how I discover this. So the fuse is off. Whoops. So the fuse is off, but yeah, I definitely burned the fuse. So I had to take my time and do things right, especially these things. I just didn't solder it. I just did a regular clip. Now it's got solder in there and everything. I think that was my bad. I hope I didn't fry anything else. Nothing looks fried. Everything looks fine. So I'm just hoping everything's fine still. And it was just a bad speaker connection. I'm about to put in a new fuse. I just had to run out to Home Depot. I got just the 3 amp fuses here, ACG or whatever they're called. So yeah, I'm just gonna put that in there and see if it works, and hopefully I don't make a stupid mistake like that again. Alright, I just tried it again, and now we definitely have a problem. Essentially, something burnt inside. It still smells. I just barely turned it on. It did some more noises, and then I spark and some kind of short. So I think I have some kind of short in there. Something's wrong. Okay, back to ground zero. This is not good. I might as well just retrace my steps and try to see what's going on, because this is not working out. All right, bad news. I have another burnt chip. I need to find out why this chip is burning. I'm not gonna install another one until I really find out what I'm dealing with here, because these chips, it's not that they're expensive. I mean, they're $7-10 each, but it's just a hassle to install new ones. Just a big pain, and I definitely think something else is the problem. If this is burning out all the time. Something definitely must be, something else definitely must be wrong. Maybe it has something to do with this mod that I made. Something is hitting. So this is exactly where the problem was. See, I'll put up a picture of this device, this panel input jack. It's actually made of metal with plastic inside, and there's actually a pin that connects the ground circuit to the chassis of the input jack that you see here. I don't know what was happening. I did remove that pin that connects it. I didn't notice any connection between ground and the chassis of the output jack, which would then ground my one of the pins to the chassis of the amp, right? Because it's all touching. I don't know if there was still some kind of connection there that I didn't notice. It's also a fairly cheap jack. I did try a Switchcraft jack later, and that was giving me problems too. So maybe I just wasn't doing something right. But I checked it many times to see if there was continuity between the ground and the chassis, and there wasn't. But there was always a little bit of like, continuity, like very high continuity when I put it in diode mode, like around 1500 or something, which tells me there's probably like some capacitance there between the two surfaces, and maybe that's how the ground was jumping, the negative was jumping into the chassis of the panel, which then jumped into the chassis of the amp, which then shorted my fuse, which then shorted my essentially my chip. I think that's what happened here. But anyway, this was a horrible idea. Whenever you get a blown fuse, don't turn on the amp again. There's probably something wrong. Fix that first, and then turn on the amp. One of the mistakes I did here is I added a new fuse and I turned on the amp again, thinking that something would be fixed, and that wasn't the case, of course. So right here I'm just discussing some of that, especially more with the jack that I installed there. But anyway, let's get back to the video. Is giving power to the chassis, but I made sure that there's no contact being made between here and the chassis. But what I might do is just take this off and forget about this mod, because this is definitely not working out, and I wasn't having this problem when these wires were directly just through. So it might just be that, but again, I'm not sure. So alright guys, so I have the power board here, and I just took it out and I noticed a couple things. First things first, I think I did that wasn't like that. This is one of the signals that goes into the EFX board. So I gotta fix that. So I started reading the schematic a little bit more, and I found out a little bit more about how the power's coming in here. So the power's coming in through these pins here. Well, first is going into this sort of isolated circuit over here. This is more the fuse circuit. Some of the direct power comes in here and it goes through the fuse. I'm not sure what else it does, but it seems to be more of an isolated circuit so that it can protect you if there's some sort of surge. But then it goes into the transformer from one of these, and then it comes back through here. And I probably shouldn't be touching that with my bare fingers because it might have power in the capacitors. But what it does do is some of the power goes straight through. Some of the power actually goes through this. This is the rectifier. Been studying some of the power supplies, how they work. Every AC power supply. Let me turn this around. Just kind of bent here a little bit. So every AC power supply is going to require some sort of rectification. So again, here, this is when I realized that I needed to check my block diagram essentially, right guys? I had another blown chip. I needed to check the smoothing section again. And now I really needed to check my rectifier section and my transformer. And so that's what I set out to do for the next couple of steps. Let me show you how I actually did that so that you can kind of get a way to test these parts, and also, you know, kind of to finalize this video that it's just now becoming way too long. So one of the first things I did was started checking the transformer, and here is the way to check a transformer. Our 1 and 2 are our primaries, perhaps this is our positive and our negative leads from the city power, and we're gonna move this into a couple of voltages, right? A 3, a 4, and a 5. And what you're gonna want to check first is resistance. This is more of a simple check with the multimeter. You want to make sure that you have resistance through this primary coil. This should be a bigger resistance value, and then you want to check the resistance between 3 and 4, 4 and 5, and then finally 3 and 5. Finally, you're going to want to check the continuity between your primary and the chassis of the transformer, and your secondaries and the chassis of the transformers. So this is how you do this roughly. Okay, here's my test, right? So we're going to check, here's the actual test that I did, right? I checked 1 and 2, and 5 and 4. Let me just kind of zoom out here, see if I can do this a little bit better. Okay, here we go. So I checked 1 and 2, that gave me 4 ohms, right? And I'm checking resistance at this point. I checked 4 and 5, so from here to here, and that gave me 0.6 ohms. So that seemed okay. I don't know what is the actual rating for this transformer, but it seemed okay, so that's what it is. I checked 3 to 4, which is here to here, another secondary, that gave me 4 ohms. And then finally, I checked 3 to 5. So 3 to 5, that should give me, you know, a sum, right? So that's 1.1 ohms, which is actually right. We have around, you know, 5 ohms, 1.1 ohms. That makes sense. So it seemed that all of that was looking fine for a transformer. And then I checked continuity. Essentially, I checked continuity between my primary and my secondary. So from 1 to 3, there was no continuity. I didn't bother checking from 2 to 3 because that's the same thing. So I just went directly from 1 to 4. That gave me no continuity, which is fine, right? There's no connection there. 1 to 5, right? No continuity. And then I did the chassis. 1 to the chassis, no continuity. 3 to the chassis, I got no continuity, and then 5 to the chassis, no continuity. So I think more or less, I know this is kind of a rough way to check the transformer, which here's a picture of my transformer. Kind of a rough way to check the transformer, but it gave me more or less that, yes, this transformer is healthy in a way. I wasn't checking inductance or anything like that, but it more or less, it is a healthy transformer. Now, a rectifier is a completely different component. This is the small component that I kind of pointed out in the video there, and I actually desoldered that in order to check it by itself. And this is obviously going to convert our AC to DC. But this is how to check this component here. First, you're going to take your positive lead from your multimeter. You're going to set it on diode mode, by the way, or continuity mode. So just make sure that you have that mode on your multimeter. If you don't know what that mode is on your multimeter, just kind of do a Google search how to go into continuity or diode mode. So you're going to want to do this check, right? From 4 to 3, you should have continuity. From 3 to 4, you should not. Okay, from 2 to 1, you should have continuity again. Sorry, I just need a reference. But from 1 to 2, you should not have continuity. So this rough test told me that my rectifier was actually okay. So then what do I do with this information now that I know my transformer is fine, my rectifier is fine. My capacitors, I did a rough test on my capacitors. They in capacitance as well. That seemed to have been fine. I replaced my fuse again after, you know, they burnt out. So all of that, the power supply should be working as expected. I think what this meant is that my only problem was, in fact, my mod. You're not going to see any more video, but what I essentially did is I replaced that mod, just went directly to the speaker, and that started working again. So that actually fixed my problem. So anyway, that's just an overview here of what I actually did. Very long story, very kind of elaborate, lots of explanations, but I really wanted to kind of dive and get into the geeky stuff on some of these things. I actually have the amplifier right here. If I can move this camera over, I actually have the amplifier right here. It's working fine. It's doing great now. I can turn it on, and you know, I'm not going to do a demo of that. All you have to know is it's working fine. I do want to I actually want to make a video where I replace the speaker and put in a Celestion and compare it to the Marvel speaker here, but that's a different story. But overall, the amp is working now, so I'm very happy that that's all fixed. One thing to note is I didn't fix anything around the preamp. There wasn't any problems with the preamp here. I do want to find another amp where maybe it does have a problem with the preamp, so I can get some experience in fixing the preamp area of the amp. But in most cases, what usually goes in an amp, and when it's actually completely dead, it's going to be something around the power supply or the power valves. So just FYI, this is one of the most common problems. But anyway, guys, thank you for watching. Thank you for sticking all the way through. This is around a 30-minute video now. I'm going to actually put all of my content, all of my pictures, all of my diagrams and manuals that I found throughout the process. So there's a bug flying around throughout the process, so that you can get everything that I got and all the homework that I did. You can just get it right down there via a Dropbox link or a Google Drive link. Feel free to grab that for yourselves. Thank you for watching. Hopefully this video helped. Hopefully it wasn't too long. I know I can be long-winded at some points, but maybe I'm hoping that you at least get some value out of it. And that's why I did this. I get so much value from the videos you guys put up. I just wanted to give something back. So not a professional video, but I am trying just to give you the plain value that you might need to fix your own amp. And let me know if you actually did fix one. I actually want to know what you did so I can learn from you and maybe watch your video someday. All right, guys. Well, thank you so much. I'll see you next time. Bye-bye.